Now it's time to talk about factors. You'll notice this first problem just has a polynomial and it says to divide it by x plus 3. So let's do some synthetic substitution, synthetic division, whatever you want to call that thing. Let me switch over to red. So we reverse the x plus 3, put a negative 3 in there. And we set this up. It's going to be 2 with a negative 3, negative 17, and 30. Our remainder is going to be down here in the bottom corner. So let's do this. Let's see, bring down the 2. We're going to multiply. It gives me negative 9. That gives me 27, which is 10, and gives me negative 30. And here's the key to the whole thing, is that what makes something a factor is that the remainder ends up being 0. Goes all the way back to long division when you were in second grade, third grade, whenever it is, and you were taught that when you get 0 as your remainder, that's a good thing. It means it's a factor. So underneath here, you'll notice there's a factor theorem. And it just simply says this. X minus r, so whatever I divide by, is a factor of the polynomial if and only if it says p of r is equal to 0. P of r equals 0 means this. The remainder of the polynomial ends up being 0. And so that kind of links in that remainder theorem also. So if you get a 0 for your remainder, it just means it's a factor. And factors are way more special than anything else when it comes to this division stuff. So I have 2 examples left. Here's the first one. It says, is x minus 5 a factor of this polynomial? If yes, find the remaining factors. So let's do our synthetic division. Put the 5 in there. Let's see, we're going to use 1, negative 7, 7, and 15. Let's see, hopefully we're going to get a 0, and then we can say it's a factor. Bring down that 1, that's a 5, that's negative 2, that's negative 10, which gives me negative 3. And there it is, that's negative 15. So it ends up having a remainder of 0. So the first question is it a factor? And the answer would be, yes, it is. Now, it wants me to find the remaining factors. See, what this is saying is that polynomial, since it divided by x minus 5, means it has an x minus 5 in it, and the other pieces are right here underneath it. And so we're going to bring that over here and call it x squared minus 2x and minus 3. Earlier, I was just done when I looked at this. But now, here's what we're going to do. We're going to factor the right side. And so our x minus 5 will stay like it is. And you would use your big X or however you want to factor this thing. You just need to factor that trinomial that's over there. So you'll notice, and I think I forgot to say it on the last problem, this original one here, you couldn't do anything with it. You can't group it. You can't use a big X. You can't do any kind of factoring to it. It doesn't have a GCF. And so you would have been stuck. But now that we divided out that x minus 5, the leftover pieces can now do something with them. So it's just a normal trinomial. That would factor into, let's see, x and x. It's a negative at the end, so one's a plus and one's a minus. It's got to be a 1 and a 3, and I want the 3 to be negative. And so this ends up being the other factors. Now, I think this is kind of important or worth looking at, is put all this information together here that you know. If I go over here to the left and just kind of sketch a graph, I want you to see a couple things. First, the polynomial that we had is an odd degree with an positive leading coefficient. So I know it finishes up because of the positive leading coefficient, and it means it must have started down because it's odd and they go both directions. Your zeros happen to come from these guys. So like this middle guy that's x plus 1, that means it had a root at negative 1. The x minus 3 means there's a root at positive 3. And then the x minus 5 means there's a root at positive 5, which would be like over here to the right. You also know that from the other day, this 15 at the end is your y-intercept, and so it'd be like up here at 15. If you connect all this stuff, look at what it does. It creates a graph like we've been looking at with an odd degree and a positive leading coefficient, all the stuff matches up. In the past, we weren't finding the roots specifically, but now we've done that, which I think makes this, I don't know, a little useful. All right, so let's try this one more time. We're going to show that it's a factor this time, which means I'm guaranteed it's going to give me 0 for my remainder because we're showing it's a factor. So let's see, I'll use my 2 here. We go 1, -7, 4, and 12. Bring down my 1, that's 2. Let's see here. And you'll notice that when I do this, I do get a remainder of 0. So by doing this synthetic substitution alone, I have shown that it's a factor because the remainder is 0. Now it wants me to find the remaining factors. So start with the one we knew already, that was x minus 2. And then put down what we found out, which is x squared minus 5x and minus 6. Now, that thing on the right can be factored. If you need to do a big X, do a big X, but factoring this one, x squared just means it's x and x. Negative at the end means it's a plus and a minus. 6 could either be 1 and 6 or 2 and 3. In order to get -5, we got to make a -6 here and a 1 here. If you FOIL that back out, you'll see that's what it is. And so that ends up getting me the remaining factors, and that's all it wants me to do on this one. Later, we're going to end up putting things and not find factors, but we'll find the zeros is what they're called. So this thing will equal 0 at the end. And so like the first one would be +2, and the middle one would be -1, and the last one would be +6. But that's where we're going. So we still have section 6.7 and 6.8 until we get to the test. But at this point, you should be ready to do the exit slip. I'm going to upload these notes to Canvas as well. And then you have a homework assignment right here. It's in Canvas. So you should be able to find it there. All right. Good luck.